Okay, we'll see if this is any better of a camera than we had. All right, we're going to start on chapter 5.5, which is counting techniques. Okay. So when we talk about the multiplication rule, the multiplication rule says that you can multiply the possibilities. Okay? All right, so let's say that a restaurant offers 2 appetizers, 4 entrees, and 2 desserts. Okay? So, I'm going to pick on Kyle. What's your favorite appetizer? Okay. Ice cream is not an appetizer. That's a dessert. Okay, ice cream. You got a dessert. Okay? Eric, what's your favorite appetizer?
Bloomin' onion.
The bloomin' onion. I love that. Bloomin' onion. How about David? What's your favorite appetizer? What is it?
Snake bite.
Snake bite? What's that?
Jalapeno cheese balls.
Jalapeno cheese balls. I know what that is. I'm going to put that. Jalapeno, whatever, jalapeno cheese balls. Okay. I should have given myself here. We're going to move the entrees down here. Entrees. Okay, we'll go with desserts. Tyler, what's your favorite dessert?
I don't know, like some pie.
Pie. Okay, plain old pie, ice cream and pie. Okay, entrees. Sean, what's your favorite entree?
Steak.
What is it?
Steak.
I can't hear you.
Steak.
Steak. Let's see whose turn is it. Austin, what's your favorite entree?
Jambalaya.
Jambalaya, really? I'm just going to call it jumbo. Okay. Stainer.
Brisket.
Brisket. I love brisket. That's good. You guys are a lot better than my normal classes. Usually they come up with horrible things. Alex, what's your favorite entree? Hamburger. That sounds more normal. Okay, so let's say that a meal consists of a bloomin' onion. Now I'm going to put O for onion. Onion and steak and ice cream. And then I've got another meal that's onion and steak and pie. Okay? So I could, as a sample space, write out every single possibility, right? If we call that 2 different meals, how many possible meals are there? And who wants to write them all out? Right? Can we figure out how many meals there would be? Ashley, what do you think?
I don't know, I think it would be like a way to calculate like something to the house.
Okay. How about the multiplication rule? Okay. How do you think you would use the multiplication rule?
All of the possibilities.
You just multiply them. 2 times 2 times 4. 2 times 2 is 8 times 4. No, 2 times 2 is 4 times 4 is 16 meals. Okay, so there's 16 possible meals. Okay, so you would just have to multiply them together. That works out pretty well, right? Yes.
What word in a problem will tell us that we have to use that rule?
That's a great question. Nothing in the problem is going to tell you. You got to figure it out.
That's not a good answer.
That's not a good answer. So hopefully you can hear that. Yeah. So, well, that's a good question. I will say this though. One of the things that we're going to ask here is, here, I'll go over here, does it repeat? That's a good thing to ask you. Okay. Now in my case with the food here, I just started listing out a few of them so that I'm going to pick one appetizer, one dessert, and one entree. Okay. So I'm going to pick one out of every group. Okay. Now, does it repeat? Okay. We can talk about factorials. Okay. So if I did say 4 factorial, that is the same thing as 4 times 3 times 2 times 1. So 4 times 3 is 12, times 2 is 24, times 1 is 24. Okay, do you guys remember factorials? All right, so let me ask you a question. I'll ask you this one. How many 3-letter airport codes are there? Okay. Now, one of the things that I like to do when I'm doing something like this is I'm going to just put 3 dashes. Okay. Now, or three blanks, I guess. So if I'm using letters, how many choices do I have for the first letter? 26. How many do I have for the second letter? I still have 26, right? Now this, and the third letter? 26. Now this assumes that I can have an airport code of AAA, right? All right, so 26 times 26 times 26 equals 17,576, right? That's just the multiplication rule again that we just learned, okay? All right, now what if I said no repeats? Okay, I can do the same thing again. Drop my 3 blanks. Ramiro, how many options do I have for my first letter? 26. I'll put my second. 25 and 24. I multiply those together. I should get 15,600, which would be some sort of a pattern like ABC. No repeats. Okay? All right, so this one is a tricky question, and Victor actually had a really good question, but I don't really have a good answer. Okay? So you just gotta kind of think about these logically. Let's say that, for example, you need to travel to, I like that this isn't going out of focus, 7 schools. How many possible routes are there? Okay. Now, would it make sense to go back to a school once you've already visited it? No. Okay, so does it say that there's no repeats in the problem? Yeah, no, it's implied. It doesn't say that, it's implied, right? Okay. So once again, my favorite thing is to say, well, I'm going to draw 7 blanks, right? 1, 2, 3, 4, 5, 6, 7. Okay. So, Tyler, how many options do I have for my first choice?
7.
For my second?
6.
The third? 5, 4, 3, 2, 1. What did I just do? 7 factorial. Okay. Now you should have a factorial button on your calculator. It probably says X factorial. Okay. So you should be able to type that in, and hopefully you should get a big number, 50,040. Okay. Now, if I were doing this in Excel, How do you think you would do it?
Equals.
Equals fact. Very good. Okay. So if I'm doing equals fact, and then I would put a 7 in here, that's 7 factorial, which is 5040. Okay? Piece of cake. All right. So let's go back here. Where's my eraser? All right, so we've got the multiplication rule. You can multiply the possibilities. We've also got factorials. Factorial. And, oh, by the way, I should ask you this question. What is 0 factorial? 1. Okay, why? Because we said so. Because it makes the math work. Okay, that's the one exception. 0 factorial is 1. We need it to be 1 in order for the math to work. Okay, so just remember that one. Okay, let's also talk about a permutation. Permutation. Okay, so permutation means there's no repetition. And it also means order matters. We've also got, and it's written as permutation of n, choose r, and that's n factorial over n minus r factorial. Okay, we also have what's called a combination. And that also means no repetition. And order doesn't matter. And it is written as n factorial over n minus r factorial, r factorial. And it's written as a combination of n choose r. Okay. Well, that barely fits on my thing. I guess it won't go any lower on the board. All right. So let's talk a little. Let's do another example here. You are betting on a horse race. There are 10 horses. How many ways can you pick first, second, and third? Okay. All right, so some questions to think about. Yes. Okay. So some questions. Can the same horse finish first, second, and third? No. No. So there's no repetition, right? Okay. Does order matter?
What is order?
Okay. So the horse. Okay. So the horse that finishes first place gets $100. The horse finishes second place gets $75. The horse finishes third place gets $50.
Yeah.
And would it matter? What if you have the 3 horses correct, but they're in the wrong order? You win no money, right? Okay. This is actually called a trifecta. Okay. So is this a permutation or is it a combination? It's a permutation, right? So this is a permutation. Okay, so it's a permutation of n. N represents what? how many options there are and how many options are there? There's 10 horses. And how many do you have to pick in the correct order? 3. Okay. So it's a permutation of 10 choose 3, which is going to be 10 factorial over 10 minus 3 factorial, which is 10 factorial over 7 factorial. Yes?
And so what is R? So R is?
R is the number that you choose. Okay, so we've got first, second, and third we're worried about. Okay? All right, so now, of course, you can do this with your calculator, but I want to show you how to do this without a calculator. We don't need no stinking calculator. So I could write this as 10 times 9 times 8 times 7 factorial divided by 7 factorial. I can cancel those. 9 times 8 is 72 times 10 is 720. We don't need no stinking calculator. Okay? Now, I'm showing you this technique because I want somebody to, on their calculator, tell me what 70 factorial is. Well, yours worked?
Mine says overflow.
Oh, yours says overflow. That's what yours was supposed to say. Or I love it when people say error. No, it's not error. But it does blow up most calculators. What kind of calculator do you have?
Excel. I'm using Excel.
Oh, you're using Excel. Excel will do it. Your calculator will not. What's your quiz going to be tomorrow? Not going to be Excel. Okay? So this technique, even though that was super easy, you may need to use that because what will happen is if you can cancel some stuff, you won't blow up your calculator. Okay? All right, so that can be useful. Let's do another example here. All right. How many simple random samples of size 4 can be drawn from a class of size 20? Okay. So for example, I'm going to pick you 4 on the front row because I remember your names. Let's say that I have a simple random sample of Ashley, Stainer, Jacob, and Trevin. Here, we'll write it down here. Ashley, Stainer, Trevin, and Jacob. Is that the same thing as Jacob, Trevin, Stainer, and Ashley? Okay. So, and if I'm not given any money, do you care what order you're picked in? Okay. So, is this a combination or a permutation? Okay, it's going to be a combination. How big's my n? Nope.
Not 20.
My n is 20. What's my r? 4. So this becomes 20 factorial over, here's what I always like to do, 4 factorial, 16 factorial. I'm just doing that formula over there, okay? Now, just remember, when you're doing a combination, the denominator, if you add them, has to add up to your numerator. So 4 plus 16 is 20. Does that make sense? Okay? Now, having said that, this is another example that I could do. Now, your calculator should be able to handle this, but I want you to practice this technique. I could write this as 20 times 19 times 18 times 17 times 16 factorial over 16 factorial, so I can cancel those, and then I got 4 times 3 times 2 times 1, right? So 3 times 2 is 6, goes into 18 3 times, 4 goes into 25 times. So this gives me 5 times 3 is 15, so this is really 15 times 19 times 17, okay? Now, that can be very useful if I have, especially if I have a number bigger than, say, I don't remember what where your calculator breaks. It's around 55, I think, or somewhere around there. So if you can do this little technique, then you can still use your calculator, I'll make sure to give you a factorial greater than 50 tomorrow on the quiz. Okay? And then you can plug in 15 times 19 times 17, which is 48, 45.
Question, how'd you cancel the 20 and the 18 again?
3 times 2 is 6. 6 goes into 18 3 times. And then 3 times 5 is 15 times 19 times 17. Okay? So you can use this so that you don't blow up your calculator. Does that make sense? All right. Let's do another one here. All right, so the Navy uses colored flags to communicate. Maybe it's the Coast Guard. How many arrangements of flags, if 5 are white, 3 are blue, and 2 are red, which is a total of 10. Okay, so if you're using these to communicate, can you, does order matter?
No.
Order does not matter?
It would matter depending on the message that you want to send.
Is that?
Depends on the message that you want to send.
Yeah, so would order matter?
Yeah.
Yes, order should matter, right? Okay. So this is a special permutation. Okay. We've got 10, so it's a permutation. We've got 10 factorial over 5 factorial, 3 factorial, 2 factorial. Okay. And that, plug it in your calculator, should be 2520. Does that make sense? All right. Now, remember chapter 5 has been dealing with probability. We haven't talked about any probability today, have we? Now's our chance. Okay? So let's say, we'll go here. Let's say a shipment of 120 fasteners has 4 defects. QC manager randomly selects 5. What is the probability that he gets exactly 1 defect? Okay. All right. So let's think about it this way. First of all, we need to know how many possibilities there are, right? Now, does order matter?
No.
No, order doesn't really matter whether it's the first one or the last one, right? So on the bottom, we're going to do a combination. Order doesn't really matter. And how many fasteners are there? There's 120, which is going to blow up your calculator, right? So we're going to have to do our little technique. I'm going to have you guys help me with this in a minute. And how many are we picking? 5. We're picking 5. Okay. Now, let's think about this for a minute. your sample space may be helpful. So you might go good, 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 bad, right? Or good, 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 bad, good, etc. The bad can move around, right? Order doesn't really matter in this case, but I am listing this because we need to kind of account for it, right? Okay, so one way we could think of this is, it says exactly one, right? So I need a combination. How many bad ones are there? There's four bad ones, right? And how many am I picking? I'm picking one. Okay. Now, how many good ones are there?
There are 116.
116 good ones. And how many good ones am I picking? 4. I'm picking 4. Okay. So that's how we're going to set it up. Now we're going to go crazy with fractions. Okay. So let's pick on Jonathan. Can you help me write out a combination of 4, choose 1?
Yeah, so you'll have the 4 factorial.
4 factorial over, what'd you say?
Over 1 factorial.
1 factorial,
Subtract
3 factorial, right? Okay. And then I'm going to pick on Victor. Can you help me do the next one? What's this combination?
The second one will be 116 factorial.
116 factorial over
4 factorial.
4 factorial
Times 112.
112 factorial. Okay, those 4s are going to cancel, aren't they? Nice. Okay. Now on the bottom, we're going to pick on Austin. Can you help me do the combination on the bottom? 120 factorial. 5 factorial. 115 factorial. Now you have to do this on your calculator because I know it'll blow it up. Okay? No Excel for you. Now we get to start writing this out here, right? So I can rewrite the 116 to what? Let's pick on Jacob. Let's work on this one. This is going to be the big one. That's going to blow up my calculator, right?
Yeah.
So how can I rewrite this so that I can use my calculator?
You can just simplify 116 and 112. Wherever that
How do I do
comes
that?
Down to.
Huh?
I don't know. Can you just simplify 116 over 112, whatever that gets you?
Yeah, if you do it right. So tell me what to write.
116.
116
115.
times 115,
All the way down to 112.
114, 113 times 112 factorial over 112 factorial. So those cancel. I've already canceled that. And then over here, I've got, what's 3 factorial? 3 times 2 is
3 times 2 is 6.
6 times 1 is 6, right? So really, so this is really at a 6, a plain old 6 times, well, times 1 now. Okay? And then on the bottom, I've got, whose turn is it? It must be, no, Samantha's turn. So we're simplifying this now.
So you can do 120, 119, so on, so you get 115.
117 to 116 times 115 factorial over 115 factorial. So those will cancel. I still got 5 times 4 times 3 times 2 times 1, right? Now, let's see here. So this 116 will cancel that 116. I was hoping I could get more than that. 5 times 4 is 20. 20 goes into 126 times. 3 times 2 is 6. Oh yeah, that goes in perfectly. Okay. So now what do I have here? I've got 115 times 114 times 113 over 6. Then this is going to be my new denominator times 119 and 119 and 117. So that Well, that's not bad. And you can plug that in your calculator, right?
Did we get rid of the 6 there? By,
Oh, the 6 is still here. Got rid of that 6 with that 6. Okay? So that's not too bad. So who can plug that in their calculator?
0.15.
This equals 0.15? Is that true?
Yeah.
Let's see here. We'll use our calculator. Now, let me share this. Sure. Let's see if I did it right. Equals 115 times 114 times 113. And on the bottom equals 6 times 119 times 118 times 117 equals this divided by that, 0.115. Okay, so now let's make sure we did it right. Do you think Excel will do combinations and permutations? Oh, I forgot to mention that. Probably. So if you were coming up with a command for a combination, what would you do? How about combin? Combination. Okay, we'll start with what we started here. This is 4, choose 1. Okay. And then we did a combination of 116, choose 4. And the denominator is a combination of 120, choose 5. Now I'm going to take my numerator, which is this times that, and I'm going to divide it by my denominator, and hopefully I get 0.15. Okay. Now, oh, I forgot to mention the permutations. We'll go back to this example here. How would you do it? So this is a combination. What do you think you'd use for the command permutation? Permut. Permutation. So if I did this one here, simple random sample size 4 from 20. So that would be 20, choose 4. The answer I got the first time was 4845. Let's see if we get that. Oh. Well, that was a combination. Anyway, there's 116,000. That's interesting. Versus 48 combinations. What was my horse race one? Oh, the flags. We can do the flags one. Permutations. Oh, I don't think this one will do that one, though. You'll have to be careful with this one. No, that one won't work. We'll do the horse race one, which was 10, choose 3. 720. Okay. I usually run out of time, and I've got like 2 minutes left. Okay, this will be a fun homework assignment, right? All right, so aren't you glad this wasn't on your test? Yeah. All right, so hopefully the sound is good. We're going to test. I will upload.